There are barriers in OpenMP, and they are similar to pthreads barrier, and that is in contrast to what is sometimes called a memory barrier, which is similar to a C and C++ memory fence. And so the OpenMP barrier, it needs a lock, a counter, and knowing the number of threads that will wait for this barrier. And an important difference between a pthreads barrier that you write in your code and an OpenMP barrier is that usually you don't have to insert it in your source code. Instead, it's implicit at the end of a parallel part of the code. So how do we create a parallel part? Well, we use this pragma OMP parallel, and then the next compound statement, a compound statement, I mean curly braces, something in curly braces, and or a for loop is executed in parallel. And how many threads are started? Well, actually, usually no threads are started, because the threads are created before we get to this part. Starting new threads as soon as we come to a new parallel part of the code would be too time consuming. So they are waiting until the main or master thread is reaching the next parallel part. And the number of threads, well, that there is a default number, but we can also set it, for instance, using this OMP num threads environment variable, as we will see shortly. Okay, so we can write like this: include omp.h pragma OMP parallel. Usually commands with hash are written to the left, but usually it's for OpenMP, it's easier to read if we write it with indentation. Okay, so what happens here is that each thread asks for its thread ID and it prints that. We don't have to run this. And okay, I mentioned this already, namely that there are the threads are created and then they wait until the next parallel section and then they are doing that, and then they wait until the master thread reaches the next parallel section. And we can also have nested parallel parts. So we will next see what happens when we run a for loop in parallel, and let's do that and see which mistakes can be done. So first I set the number of threads using an environment variable, and this is how you do it in Bash and also in other command line interpreters in the terminal. Okay, so now let's edit this file, and okay, it includes OMP and standard IO. Okay, and now I have this is using VI editor, not Vim, and what I have done is to map the key V to run make. Okay, and then it will do this make file. Oops. So it will just compile and run the program. So let's do that. Okay, what happens? We have 4 threads, and they did not all of them go to all the iterations. So we might have expected there should be 3 iterations printed out, but it was not. And okay, so there are two problems in this code. And the first is that all the threads use the same I, and that's not what we want. Partly because it creates a lot of communication, cache misses, between the threads, so it's not a good idea to use the same loop variable. And also, the program doesn't work as we might have hoped. Okay, so what we do is to say that this I should be private. And we do it. Now, it works better. But, as we can see, each thread is doing this parallel part. So it's the, I mean, all the 4 threads do this for loop. So instead we can do it like this, parallel 4. And now the work is distributed so that the 4 threads, I mean, each thread gets to do 1 iteration as long as there is an iteration for that thread. And we can also see that they are not doing them in any particular order. So our program should not rely on that. And when can we use this? Well, it is up to the programmer to analyze the loop and see that it really can execute in parallel and get the expected result. Or at least, I mean, we cannot expect any particular loop ordering here, but correct result.